Hello, grade 12. Welcome to the grade 12 mathematics summer lesson, and we are still continuing with functions. This is our part 2 where we'll be focusing on the inverse functions. Okay, let's take a look at the content outline. As you can see, we are done with the 7 sessions on topic 1. And we just did our part 1 on functions, where I was introducing you to functions, where we were defining and exploring different types of functions and how to really understand how we can identify functions and all that. So this is unit 2, and this is part 2, where we are going to be focusing on the inverse functions. Don't forget, we are still using 2 textbooks, Platinum Mathematics Learner's Book and also Mind the Gap Mathematics Study Guide. Okay, the inverse functions. Inverse function. How do we get the inverse of a function? Okay, so if a function is reflected about the line y equals to x, very important, then the new appearing graph will be known as the inverse function, right? So take a look at the line y equals to x. It is this straight line here that passes through the origin. This is the line y equals to x, right? So if I have a graph and I reflect it about this line y equals to x, the new graph will be known as the inverse function. So we obtain the inverse of the function by swapping x and y values. Why? It is because this line is y equals to x. So now from this line, if you reflect anything about it, the new things will be known as the inverse of the original, obviously. So to get those new graphs or points, we can swap our values of x and y, because you can see if I'm reflecting about this line y equals to x, it means my y is now becoming my x, and my x will now become my y. For example, if I have a point, let's say for instance we have a point -2 and 5. So if I need to get the inverse of those points, if I reflect them about the line y equals to x, then I have a point -2 and 5. Then you can see that by swapping the x and y values, we get, if it was x and y, we'll get y and x, and that's how we can get the inverse. So the inverse of those points, we just swap the values, then it will be 5 and -2. If I go 5 and -2 somewhere there, 5 -2, you can see those new points are the inverse of the original point. So I can just put something like this here to show their inverse. So that's how you do it. So because you are reflecting about the line y equals to x, so the new things becomes the inverse. So you just need to swap those points there. Okay, so also in your graphs, you can see that now if you are swapping and we are getting the inverse, the values of x are now changing to become the values of y, and the values of y are now changing to become the values of x, and this will really affect the domain and the range of the inverse. It won't stay the same, right? It won't stay the same. So now the domain, which are the values of x in which our graph is going to take, or in which our graph is covering, will now becomes the range, because remember we are swapping the value of x and y. So the domain becomes the range, and the range will now become what? The domain in the inverse. So that's how is it. So let's also look at the notation, how to represent an inverse of a function. For example, if I have an original function f of x, then we use f to the exponent -1 to represent the inverse of f of x. So its inverse will be in this notation f exponent minus 1x. So obviously if the graph is f of x, then its inverse will be f exponent minus 1x. So be very careful not to mistake the minus 1 in the f minus 1 there of the exponent as a reciprocal. So this really f of minus 1 exponent f of exponent minus 1x does not mean the reciprocal, which most students can confuse to say this is 1 over f of x, right? So it's not the same as that. Remember, the minus 1 is on f, so it's not on the whole thing. So this is the notation that is used to represent what? The inverse of a function, if maybe our function was f of x. Okay, let's take a look at how you can find the equation of an inverse function, right? So they can give you an original function. Let's take, for instance, they give you an equation f of x equals to something, then the equation will say determine the inverse of this function. So the first step is you have to replace f of x by y, right? So if you are given g of x, if you are given p of x, if you are given h of x, like that, you'll have to replace them by y. So that's the first step. Then step number 2, remember we're determining the inverse. You'll have to swap x and y. After swapping x and y, you'll have to solve for y in terms of x. Now you want to determine the equation. So you have swapped x and y, then you'll have to solve for y in terms of x. Then after solving for y in terms of x, then you can now replace y by the symbol of the inverse, right? Because you have now determined the equation, so you can substitute f exponent minus 1x as as the inverse of your function. If it was g of x, you'll just replace that y by g exponent minus 1 into x. So but sometimes they can just say determine the inverse of function f of x in terms of y equals to, so you'll just end up on step number 3 where you have solved for y in terms of x, right? Where you just leave your equation as y equals to something. But if they just say determine the inverse of this function, they will tell you the notation, whether they want it in this notation or they just want you to end on step number 3 where you have to just write y equals to, then you have determined the inverse. So just to repeat this very quickly, step number 1, replace f of x or g of x or h of x, or if you are given p of x by y, then you swap x and y. This is the most important step. You swap x and y, then you solve for y in terms of x. Then that equation would have been your inverse. Okay, let's just take a look at this example so that I can just really quickly show you how you can determine the inverse. You are given a linear function f of x equals to 2x plus 6. Then the first question say determine f exponent minus 1x. You know that this is the notation or the symbol for the inverse, right? So the first question really wants you to get the inverse. What's the first step? The first step is to replace f of x by y. So where there is f of x, we're just gonna replace by what? By y. Then the second step is say swap x and y. We need to swap x and y because we are reflecting this graph about the line y equals to x. So where there is y, we're gonna put x, and where there is x, we're gonna put what? We're gonna put y. Then the third step is solve for y in terms of x. So we need to solve for y. So in order to solve for y, I'm going to take 6 to the other side to be minus 6 equals to 2y. Then to solve for y, I divide both sides by 2. These 2 cancel these 2. Then I have y equals to x minus 6 over 2. But I can just simplify this to say x over 2 minus 6 over 2. Then it's going to be, let's see, x over 2 minus 6 over 2 is 3 as my y. Then I can replace y by the symbol of the inverse. So where there is y, sorry about this, where there is y, I'm going to replace by the symbol of the inverse. and this is x over 2 minus 3. I can put it properly to say it's f, this is the symbol of the inverse, x over 2 minus 3. So this is our inverse. So it's very simple to determine the equation of the inverse. Just follow the steps and you do the things there. Okay, let's look at question 2. It says sketch the graphs of f of x, its inverse, and y equals to x on the same set of axes. So now here it's where you'll get to know how to sketch the inverse of a function, right? So I'm going to first sketch the graph of f of x. So I have f of x equals to 2x plus 6. You know this is a linear function. In order to sketch this graph, I can just calculate the x intercepts and also I need to know it's y intercepts, right? The x-intercept and y-intercept. So the x-intercepts, we let y to be equals to what? To be equals to 0. So when there is y, I put 0. Then so for x, then it's going to be minus 6 equals to 2x divided by 2, then x is equals to minus 3. So my x-intercept to be minus 3 as my x and my y, which was 0. Okay. So to get my y-intercept, we let x to be equals to 0. So where there is x, I'm going to put 0. Then it's 2 into 0 plus 6. Then we know that my y-intercept will be 6. So y-intercept coordinate x was 0. Then my y was 6. So these are my x-intercept and y-intercept. Okay. So I can go and sketch this graph. Look at this. This is x and this is y. Maybe I should use a different color for because they said we must also sketch y equals to x. So y equals to x will just be that graph that is moving, that straight line that passes through the origin. Let me just maybe extend it. Then for this one, maybe I can use a different color, maybe blue for the original graph f of x. I have my x-intercept as minus 3. This is where my minus 3 is, or maybe let me use dark. This is where my minus 3 and 0 is at this point. And 0 and 6, 1, 2, 3, 4. Okay, I'll need to extend this line. So I don't know whether this will work. 1, 2, 3, 4, 5, 6. Great. So that is where I have my 0 and 6. So I can just join those 2 points in order to sketch this graph. Okay. So if I'm joining the 2 points, unfortunately I'm not using a ruler. So this is my f of x, right? This is our f of x. So now to sketch the inverse, it's very simple. Let's go and sketch the inverse. I'll just use a red color, maybe dark red. To sketch the inverse, what do? We swap the points of the original graph. So we are going to swap the points. Oh, I forgot to write this one. Here it was minus 3 and 0. So to sketch the inverse of this graph, we just swap the points of the original graph, you see. So it's very simple. So you just swap the points, or because you have already determined the equation there, you can just go and sketch that graph. But an easier method, you just need to swap the points of the original graph, because the inverse is just reflected about the line y equals to x. And let me just also indicate this is the line y equals to x. So to sketch the inverse, I'm going to swap the points. When I swap the points, let me also indicate it here that these new points are for the inverse, right? Okay, so just look at the table here. So if for the inverse, the x-intercept will become the y-intercept, right? Because you are swapping. So this was the x-intercept. You'll see it's going to be the y-intercept, because when we swap, the point is 0 and minus 3. So it's 0 and minus 3. So you can see the x-intercept now has become the y-intercept, because it's now our x is 0. So you can see the domain has become the range like that. You see the idea of saying the domain becomes the range becomes the domain. Also the x-intercept becomes the y-intercept, the y-intercept becomes the x-intercept. So when we swap this one, it's gonna be 6 and 0. Then we can sketch, right? 0 and minus 3. Let me go and look for 0 and minus 3. Minus 3 somewhere here, and this is my 0 and minus 3. And let's go to 6 and 0. 1 2 3 4 5 6. Okay, 6 will be there, so I need to extend a bit here to see this is our x and our 6 is here. This is 6 and this is our 6 and 0. So if I join the 2 points, it's gonna be like this, although I can't show you more that side because of limited space. But this is our inverse. Very simple. How do you sketch the inverse? You swap the points of the original graph. You can see that this new graph has just been reflected about this line here, y is equals to x. I mean, this new graph is just the reflection of this one, f of x, about the line y equals to x. So it's inverse, and you just get it by swapping the values like that. Okay, great stuff. Let's explore this different example. And here you are given a quadratic function or a parabola, and the first question says sketch f of x. So it's number 1a. They want you to sketch f of x, which is equals to 2x squared. Okay, before sketching it, we can determine the x-intercept, y-intercept, and because this is a parabola or quadratic graph, we'll also need to know the turning points, right? So for x-intercept, if we have to let y is equals to be equals to 0. So we have to let y to be 0. So our f of x will be 0, and we need to solve for x. So you'll notice that when you divide by 2 and you apply the square root, your x is just basically gonna be 0. So it's 0 and 0 as your x-intercept. Y-intercept. So for y-intercept, we let x to be equals to what? To be 0. Then where there is x, I'm gonna substitute 0 squared. Then you'll notice also your y-intercept is 0 and 0. So for turning points, let me just write TP for turning points. So we need to have the x for turning points and also the y for turning points. So x for turning points, there's a formula that you use to calculate the x for turning points is minus b over 2a. If you don't know it, just write it down. That's the formula that you use to calculate the turning points for a quadratic graph. So if you check your quadratic graph, there's no b, it's 0. 2, what is your a? The coefficient of x squared, which is 2. So minus 0 over 4 will be 0. Okay, so to get the y at turning point, what you do, where there is x on f of x, you just go and substitute your x at turning point. So where there is x, I'm just going to substitute my x at turning point on my equation, then I get my y at turning point. So you can see if I substitute my x at turning point, which was 0, then it's going to be 0, and also the turning point is 0 and 0. Okay, let me show you how this graph will look like. Okay, so this is basically how the graph will look like. You have your turning point and your x-intercept, y-intercept, they're at the same point, is 0 and 0. So I just calculated also some points. I substituted 1 where there is x, then I get y as 2. I substitute 2 where there is x, then I get my y as 8. Also this side, when I substitute minus 1, I'm getting 2, minus 2, I'm getting 8, and just to get how this graph will look like. So that's my A. Let's go to B. What really I want us to focus on. So it says determine the inverse of f of x, right? Determine the inverse of f of x. So we have our f of x is equals to 2x squared. And to determine the inverse, we say step number 1, you have to replace f of x by y. If maybe you are given h of x, g of x like that, you will replace them by y. So where there is f of x, I'm going to replace by y. Then it's going to be y equals to 2x squared. Step number 2, it says swap x and y, because this is a reflection about the line y equals to x. So where there is y, I'm going to put x, and where there is x, I'm going to put y. So we have our squared there. So don't make that mistake of maybe when you are swapping, you just put x squared equals to 2y like that. So most students can make mistake here in terms of swapping. So be very careful. When you swap, you just swap the x and y. If there is square, the square will remain there. So where there is y, I put x, and where there is x, I put y. So the other step is to solve for y. So when I solve for y, just gonna divide both sides by 2. Then it's gonna be x over 2 is equals to y squared. Then to solve for y, I'm gonna apply the square root. Then it's gonna be plus or minus root of x over 2. Then my y will be equals to plus or minus root of x over 2. So this is the equation of the inverse. I can just replace by the symbol of the inverse as the last step. Where there is y, I put the symbol of the inverse. F exponent minus 1x is equals to plus or minus root of x over 2. Don't forget to write plus or minus, because this is a square root, right? Okay, so that's the equation of the inverse. Okay, the last question, C. It requires us to sketch f prime. F inverse of the inverse of f of x and the line y equals to x on the same set of axes as f of x. So I'm just gonna sketch it on this plane here. I already sketched f of x. Then I just need to sketch the one for y equals to x. The line y equals to x will just be that line that will be moving there like that. Or maybe I can use a different color, green, to just show you the line y equals to x like that. This is the line y equals to x, right? So the one that just passes through the origin and goes there. Okay, so to draw the inverse, I'll just use a red color. So to sketch the inverse, we're gonna swap the points, right? We're gonna swap the points, and let me show you the maybe a table of where we're gonna be swapping the points. Okay, so this is the table. If I'm swapping this point to get the one for inverse, it's gonna remain 0 and 0. Even if you swap 0 and 0, is 0 and 0. This one, when it's swapped, it's gonna be 2 and 1, and this one is gonna be 8 and 2. This one is gonna be 2 and minus 1, and this one is gonna be 8 and minus 2. So these are our new points, or for the points for the inverse. So you just need to swap the points of the original graph in order to sketch the inverse. So 0 and 0, our inverse is gonna be still there at 0 and 0. 2 and 1, let's go to 2 and 1, somewhere there. It's gonna be our 2 and 1, and we have 8 and 2. Is it 2 and 1? 2 and 1. Okay, great. 8 and 2. 1, 2, 3, 4, 5, 6, 7, 8. Just here, and 2 probably there. That's our 8 and 2. And we also have 2 and minus 1. 2 and minus 1 somewhere there. Okay, sorry about that. Let me see. So that's 2 and minus 1, 2 minus 1. And also we have 8 and minus 2, which is roughly maybe there. 8 and minus 2. So you can see the inverse is sort of like different here. It's like this, goes like this, then it comes again like that. Sorry for that bit of messy shape. Yeah, so that's the inverse. You can see it's like the parabola. They took the parabola and they slant it or change or they slide it to face the x-axis or in that way. So that is our inverse. So every time when you see this graph like this that is slanted like this, slided towards like its arrows pointing the x-axis or positive x-axis, sometimes it can be it can be facing the negative x-axis. Just know is the inverse for a parabola graph. So that's basically its shape and how you sketch it. You just swap the points of the original and you can sketch it like that. Okay, let's explore a different parabola question. This is an example obviously, and it's quite challenging, but it's a bit simple. So it's just basically one of the things that I want you to learn. They can ask you to calculate the inverse but on a parabola, but they give you certain restriction. In this case you are just given g of x equals to minus x squared, but you where x is less or equals to 0 and also y is less or equals to 0. So those are the given restriction, and I want you to know how you can calculate the inverse given this restriction. So it's our a, we have our g of x is equals to minus x squared. So they say write down the inverse of g, which is this symbol g exponent minus 1, but we are writing it in the form h of x equals to, right? So that will be our inverse. So to get the inverse, we replace g of x by y. That's the first step, right? So after replacing by y, let me just write this y properly. Then we're gonna swap x and y. Where there is y, we're gonna place x, and where there is x, we're gonna put what? Y. So after doing this, we can divide both sides by minus 1. If I divide by minus 1, I'll have minus x is equals to y squared. Solve for y, right? So we solve for y by applying the square root. Don't forget plus or minus. So it's going to be plus or minus x. Let's wait here and look at the restriction. From the restriction, they are saying where x must be less or equals to 0. So what does it mean? If you check, our x in the square root is already less or equals to 0. It's already negative, would always be less or equals to 0. So we won't change that one. It will remain that one, right? And where y must be less or equals to 0. So your y must be less or equals to 0. It means that they're telling you your y must be less or equals to 0. This whole thing here, it must be negative or less or equals to 0. That is negative. So it means rather than saying plus or minus, they are telling you the final answer for your inverse, how it should be, right? So then we can conclude, therefore, y is equals to, for it to be less than 0 according to this restriction, it must be negative. It must be negative. That's negative there. Root of minus x, right? So it's root of minus x. So that's the final answer for the inverse. So we can also write, because they said they need it in this form, h of x equals to something. So where there is y, I'm just gonna replace by h of x equals to minus root of minus x, right? So that's the inverse. We can also write the restriction given there to say where there is x, we can replace by y less than 0, and where there is y, replace by x less or equals to 0. So this is the new this is our inverse with those given restrictions. So be very careful if you want to calculate the inverse of a parabola. They can give you those restrictions. You also have to use them in order to find the final answer. Okay, let's take a look at restricting the domain and range. So You can find that you have your, take a look at the picture that I just put there. You have your many to one function. If you use a horizontal line, you realize this is a many to one function. So most of our many to one function, if you sketch their inverse, just take a look at this inverse here. Let me highlight it in red. Here is it. If you take a look at their inverses and you apply the vertical line to check whether they are function or not, you'll notice that they are not a function because the vertical line cuts that graph at more than 1 point, right? So as thus mathematician has discovered that no, actually, because the inverses of many to one function will never be a function. For example, a parabola, a quadratic function, we can however restrict the domain of this function in order to make its inverse a function, right? So this is where we now have to think, how can we restrict the domain of this function, of this many to one function? In most cases it will be a parabola graph or what is known as a quadratic graph. So how can we restrict its domain so that when we draw its inverse it can be a function? Because if we take the whole domain, if you take a look at this parabola here, its domain, when we say domain, we are saying the values of x in which the graph is covering, right? So if you take a look at this part, it will be covering all the positive x values. If you take a look at this part, it will be covering all the negative x values. So that's why we can say that its domain is x is the element of all real numbers, right? So because it's covering both positive and both negative sides. So but if we take that domain and sketch it inverse, you're gonna get something like this. Let me use a red color. This is its inverse, right? But it's not a function because the vertical line cuts it at more than 1 point. So it's not a function. So what we have to do is we have to restrict the domain of the original function so that when we sketch its inverse, it can be a function. And how do we restrict a function's domain to make its inverse a function? So if f of x is a parabola with a turning point P and Q, then the restriction of the domain will be x must be less or equals to P, or x must be greater or equals to P. So basically what you do is, in order to restrict the domain of this function, what we are going to do is we are saying we're gonna take only one part of the graph, right? So, and we restrict the other part. For example, when we say x is greater or equals to P, we are saying x must be greater because here is the turning point. If you say x is greater or equals to P, you are only taking this part. So when you sketch the inverse of that part, you are going to definitely, if you swap the points and all that, you are going to get this part here, right, as the inverse of this part. So if you sketch a vertical line, you realize it's now a function, right, rather than using the whole part. So that's how we restrict the domain of the original graph in order to make its inverse a function. Or also we can say x is less or equals to P. So we are saying when we say x is less or equals to P, it means we are taking this part. So because we are only including the values that are less than that x value of the turning point, so we are using this part. When you sketch its inverse, you're gonna get this part, and you notice that when you apply the vertical line on that one, it will only cut once, meaning you have ensured that its inverse is a function. So that's basically how we can restrict the domain of the original graph so that its inverse is a function. Very, very important information. Here is it. You just check the turning point. You just say x must be less or equals to P. You are showing them I'm only taking one part, or you can say x must be greater or equals to P. You are showing them I'm also gonna take only one part, so that when we draw, only one part of that graph can appear so that it can be a function. Okay. Let's take a look at this example 1, just to enhance your understanding on restricting the domains in order to make the inverse function. Okay, so the first question, it says determine the domain and range of f. You are given f of x equals to minus x squared, and you are also given the line y equals to x. So A, it says determine the domain and range of f. The domain and range of f. So what do we mean by domain? When we say domain, we want the value of x that the graph is covering, right? That is what you call the domain. The values of x that your graph is taking up, or that your graph is covering. So look at this portion, this side, this part of the graph is covering the x values that are negative, and this arrow shows that this will go to infinity, so it will cover all the negative x values, and this side is going to cover all the positive x values like that, because this arrow is showing that it will increase to infinity like that. So it's covering all the positive x values. So you can see all positive values and all negative values are gonna be covered. So the domain will be x is the element of all real values, right? Sorry for that. X is the element of all real numbers. So that is our domain. Or sometimes one might like to say, because this part is covering all negative, this part is covering all positive, one can say x is the element of minus infinity to positive infinity. So you can choose to write it in that way, or saying x is the element of all real numbers, or you can choose to write it in this way, to say x is the element of minus infinity to positive infinity, to show it will cover all values like that. Okay, let's go to the range. The range of a parabola. How do you get the range? You can memorize or you can understand. So I'll just teach you how to understand this, rather than to give you sort of like certain formulas that you just memorize, in case, because sometimes they can like to trick you, and if you just memorize, it's a trouble. So range, when we say range, we are talking about values of y, right? So now we focus on values of y to say what are the values of y that our graph is covering. That is what we call the range. So if you check values of y, we have to look at the y-axis there, right? This is the y-axis that I'm highlighting. And our graph starts from 0. You can see it will start from 0 and moving upward, right? We are focusing on the value of y to infinity. So one can say y is the element of from 0, so 0 up until infinity. But be careful with the brackets here, because our graph is also including 0. We use a square bracket, right, rather than using this curved bracket. So we use a square bracket to show that 0 is also included up to negative infinity. So it's up to negative infinity. So if there is negative infinity like that, we can say from negative infinity until we reach 0, right? So and then we're gonna use our square brackets like this, because when you use this interval, you start from the smallest to the biggest. So from negative infinity down there to negative infinity up until we end where there is 0. So that's our values of y that our graph is covering. Or the easier method you can use is just to say y is starting from 0 going down to the negative. So y is gonna be less or equals to 0. So I think this is quite simple to see, to say y is gonna be less or equals to 0. So it's gonna be less or equals to 0. It's starting from 0, minus 1, minus 2, like that. All those values that are less, it's gonna be covering them. So that's the range, and that's basically how you get it. Okay, the second question that I really want us to focus on, it says restrict the domain of f so that its inverse is a function. Restrict the domain of f so that its inverse is a function. So if you can see, we have our turning point there as being 0 and 0. So if you know the turning point, it's easier to restrict, right? Because you just choose one of the part. You can choose to say x must be less or equals to 0. You are choosing this side so that you may have one part, or you can also say x must be greater or equals to 0. But this is directed by p, which is our domain. So in order to restrict, x must be less or equals to 0, or someone can say x is greater or equals to 0. So by saying x must be less or equals to 0, you're saying I'm going to use this part only of the graph, then so that when I draw the inverse, it can be a function. By saying x is greater or equals to 0, you're saying I'm choosing to use this portion where my x is positive, or they're greater or equals to 0, so that when I sketch my inverse, it can be a function. So this is basically how you restrict the domain so that its inverse can be a function. So when x is less or equals to 0, or x is greater or equals to 0. Okay, let's take a look at example 2, and you are given a parabola again, f of x equals to minus into x minus 1 squared minus 2, and you are also given the line y equals to x. So the first question, A and B, I'll give you these two questions as your fun, as part of your fun activity exercise, and just drop your answers on the chats, and let's see if you can try to get this correct. So let me focus on C really, because this is just some new content that has been added in your grade 12. So it says restrict the domain of f so that its inverse is a function, right? This is kind of different to the two examples that I've used, because now look at this parabola. Now its turning point is on 1, because this is 1, and on minus 2, right? So in order to restrict the domain so that its inverse can be a function, it means don't forget that we use the p that is the x at turning point, right? And how do we use it? Just check, because at p it's where you have your axis of symmetry there, where you can just split the graph into 2 equal halves. So in order to restrict, you can choose to go with this part to say, I'll say x must be less or equals to 1, not 0 this time, but 1, because here x is 10.1. So if you are using this part only, you just say x must be less or equals to 1. Or if you are choosing this side to go with this portion of this side, so you will say x must be greater or equals to what? Equals to 1. So then you would have restricted the domain, just not to use the whole domain, so that when you draw the inverse, it can be a function. So basically that's how you restrict. You say x must be less or equals to 1, or x must be greater or equals to 1. So that's our answer. Okay, so write your A and B as your fun activity exercise for this session. Okay, this marks the end of our session. Thank you very much for joining. Don't forget, this was function, and it was our part 2, where we were focusing on inverse function and also restricting the domains so that we can make the inverse functions, and also just some quick revision on how to sketch the graph, how to sketch the inverse, how to calculate the inverse, and all that. Okay, so watch out for our next session, where we'll be focusing on exponential functions and our new content in grade 12, which is logarithmic functions, and how we can determine the inverse of logarithmic functions, and also some logarithmic rules that will be very, very useful when you also do finance, very useful in function, and I think it's also very useful on your question 1 if they can give you and also number patterns. So it's going to be a very important session. It will be our part 3, and we'll just upload it in the coming days very soon. Okay, so for today, that's enough. Thank you for joining. Thank you for watching. Don't forget to subscribe. Don't forget to like, just to encourage us to just make and keep on making these quality content videos. Thank you very much. Enjoy the rest of your day. That's all for me, and goodbye.